Have you ever wondered what would happen if Jupiter was a star instead of a planet? This is a question that has tickled the curiosity of many, from esteemed astrophysicists to casual stargazers. Imagine peering into the night sky to see not just one, but two bright celestial bodies illuminating the darkness. Jupiter, the largest planet in our solar system, is often compared to a star due to its massive size. But how does it stack up against our Sun or other stars in the universe? Well, despite its impressive size, Jupiter is only about 1,000th the mass of the Sun. If it were to transform into a star, this discrepancy in size would certainly play a significant role in the process. This hypothetical scenario opens up a Pandora's box of possibilities and questions. So, what would it take for Jupiter to become a star? Let's delve into the world of astrophysics. Jupiter becoming a star, is it possible? Well, scientifically, it might be a tall order. Now, why is that? It all boils down to the colossal concept of mass and the elements that Jupiter is composed of. You see, Jupiter, despite being the largest planet in our solar system, is still not massive enough to become a star. The reason is simple, yet profound. Stars are born when an accumulation of gas, primarily composed of hydrogen and helium, becomes so dense and hot that nuclear fusion begins. This process involves the transformation of hydrogen atoms into helium, releasing a vast amount of energy in the form of light and heat. This is what gives a star its brilliance and warmth. Jupiter, although composed of the same elements, lacks the mass necessary for this process to kick in. For Jupiter to ignite into a star, it would need to be about 80 times more massive than it currently is. That's quite a growth spurt, isn't it? To put it into perspective, imagine trying to gather all the other planets in our solar system and adding them to Jupiter. You'd have to do this over 1,000 times to reach the required mass. It's a bit like trying to turn a bicycle into a jumbo jet by adding a few extra wheels. It's just not going to fly. Moreover, Jupiter's composition isn't quite star-grade either. Along with hydrogen and helium, it contains heavier elements like methane and ammonia, which dilutes its potential for nuclear fusion. In essence, Jupiter isn't pure enough to become a star. Finally, let's not forget about the temperature. The core of Jupiter is incredibly hot, but not nearly hot enough for nuclear fusion. It would need to be about 15 million degrees Celsius, which is over 3 times hotter than its current temperature. So, as far as science goes, Jupiter can't naturally turn into a star. But what if we could artificially make it happen? Now, let's imagine an extreme scenario where humans can make Jupiter a star. What would happen? Jupiter, the gas giant, has often been referred to as a failed star. Its composition, primarily hydrogen and helium, echoes the makeup of our own Sun. However, Jupiter is a mere 1,000th the mass it would need to be to ignite nuclear fusion and become a star. But for argument's sake, let's entertain the idea of artificially triggering this process. To turn Jupiter into a star, we'd need to increase its mass, or somehow bring its existing matter closer together. This might involve firing dense matter into the planet or using advanced technology to compress the existing material. If we succeeded, the resulting star would be a red dwarf, far smaller and cooler than our Sun. In fact, it would be so small that it would barely qualify as a star. This artificial star, while fascinating, would hardly provide any additional light or heat to the solar system. But the consequences of this celestial transformation would reverberate far beyond the boundaries of the Jovian system. The gravitational balance of our solar system, delicately maintained over billions of years, could be thrown off. The orbits of nearby planets might be altered, with catastrophic effects. Imagine the Earth being pulled out of its life-sustaining orbit, or Mars being pulled closer and becoming more hospitable to life. Moreover, we would essentially be creating a binary star system. This is a solar system with 2 stars, a phenomenon not uncommon in the universe. However, the stability of such systems is a subject of much debate among astronomers. But let's be clear, this is all hypothetical. The energy and resources required to trigger nuclear fusion in Jupiter are far beyond our current capabilities. And even if we could, the potential destruction of nearby planets and the disruption of our solar system's balance make this a scenario best left to science fiction. It's clear that transforming Jupiter into a star could have catastrophic consequences. But let's not forget, this is all hypothetical. In the aftermath of such a cosmic event, how would life on Earth be affected? Let's delve into the possible outcomes. Firstly, the night sky as we know it would undergo a dramatic transformation. No longer would we gaze upon the serene beauty of a star-speckled canvas. Instead, the sky would be dominated by two radiant orbs, our Sun and the newly ignited Jupiter. This double sunset, reminiscent of scenes from science fiction, would become our new reality. But it's not just about the aesthetic changes. The appearance of a second sun could bring about drastic climate changes. With an additional source of heat and light, Earth's temperature could potentially rise, disturbing the delicate balance of our ecosystem. The polar ice caps might melt at an alarming rate, leading to a significant rise in sea levels and potentially catastrophic flooding. However, it's not all doom and gloom. The additional heat and light might also mean that previously uninhabitable regions on Earth could become viable for life. This could lead to a redistribution of species across the globe, and who knows, possibly even the emergence of new life forms. Turning our gaze beyond Earth, the transformation of Jupiter into a star could also have fascinating implications for our neighboring planets. For instance, Mars, a planet often considered for human colonization, could benefit from the additional heat and light. This might make the red planet more hospitable and accelerate our plans for establishing a human outpost there. But before we let our imaginations run wild, let's remember that these are all speculations. The transformation of Jupiter into a star is not scientifically plausible with our current understanding of physics. The mass of Jupiter is simply not sufficient to trigger a nuclear fusion reaction, a necessary condition for star formation. In conclusion, while the idea of Jupiter as a star is fascinating, the scientific and potential catastrophic consequences make it a scenario best left to science fiction.